Okay, welcome back to the final installment here of our I2C devices tutorial. I'm going to walk you through how we set this up, but we have two LCD monitors. This one is a 20 by 4, and it's giving a little message and then the date and the time. This is our LCD number 2, and then we have a smaller one. This is a 16 by 2 LCD screen that's also giving the date and time. And then this little guy here is our real-time clock. Now, all of these are I2C devices, all right, which means that they all run on 4 pins, all right. It's a ground of VCC, which is our 5-volt power. SDA is the data line, and SCL is the clock line. And the microcontroller of choice right today is the Teensy 4.1. We love the Teensy product with this nice Patent Robotics motherboard. And if you want to know how to set all this up, I would recommend watching the other videos, which are down in the description. But you would know if you have been following that the A4 line is the data. A4 is the data on the Teensy 4.1. Really, all the Teensies. The data for I2C is as A4, and then A5 is our clock line. And those go to the signal pins, which are the pins closest to the board. Again, this Patent Robotics motherboard is to die for. And then what I had shown in previous videos was all of this connected through a breadboard, but I got my little board made and it was delivered yesterday, so I cut them up and my students soldered them up for me. And these guys here makes it really easy. This little board makes it really easy to connect all of these devices together. And I'm going to show you how that's done right now. All right, so the first thing we want to do is connect wires to power and ground, and then our SDA and our SCL pins. Okay, the way I like to do it is just with the 3-conductor cable, which conducts a ground on the outside, like the black wire, and then power, and then the signal to SDA typically. All right. And the reason for that is if you look on the back of your I2C devices, it goes in that order. It goes ground and then VCC and then SDA. So a 3-conductor cable connects those, and then just a singleton will conduct the SCL pin. All right, so I've got a 3-conductor cable, and I'm just going to make sure, this is important, that you see on the board here, this outside pin here is ground. The ones down here along this edge, those are the ground pins. So I'm going to just super duper check to make sure that my ground wire, my black ground wire, is on that ground bus right there. Okay, and I'm going to also double check that that ground wire is on my ground pin on the motherboard, which it is. And then finally, this little blue wire here is connected to the clock pin, and the clock pin is on the opposite side of the little breakout board, the little bus, I2C bus. And you can see, just to verify, SCL, that's our clock pin. That's on the very edge. Hope you can read that. It's super tiny. There. And so now this board is set up and it's ready to accept other I2C devices. So the first one I'm going to grab is this one here, which is just our real-time clock. Okay, and again, ground, VCC, SDA, and SCL. So my singleton is the clock. I always want to keep the same order all the time, so I don't have to think about it. So now I'm just going to plug this one in, and I can plug this into any of these because they're all common. I could plug it into this one right over here, like that, or I could just follow along, make it easy on myself, and plug it into the next one. Notice as soon as I do, my real-time clock gets a little bit of power going. It still won't work, right, because I still have to connect the clock pin from my real-time clock to the clock pin over here. See what I'm doing there? All right, so the real-time clock is connected and ready to go. I'll do the same to our little LCD screen. Again, making sure of ground and power and signal in the right order, and then my clock pin will just be the next one. Again, it doesn't matter which order you go. So that one is done. Notice it's garbage, right? It's just garbage because even though the Teensy is running the right code, this was connected after it initialized the LCD screens. So we're going to have to just run it again for it to make any sense. All right, and now I'm going to connect my big one. These wires are really twisted, don't want to behave. And then I've got this guy here. All right, there they are, right there, boom, boom, boom. All right, we want to make sure that metal doesn't touch metal, right? But otherwise, this is ready to go. All right, so let's leave it here. I've got it connected to my computer, and let's take a look at that code. So this code here, the multiple I2C, RTC, and LCD clock, that's a mouthful. This code is in the description below, and I hope it all fits. All right, so it's a combination of really two sketches. It's the RTC read time, and it's the LCD I2C sketch. Okay, I'm using the DS3231 RTC, which is super, super common. This is where I got it on Amazon. Just do a search for real-time clock, and then boom, this one's going to be the one that shows up. The library for this is already installed. When you have a PCRduino installs this library automatically. It may also be auto-installed if you have an Arduino. I don't know. I can't remember. All right. In case you're keeping score at home, I did use the RTC set time, which is for my students. This is a sketch that I wrote for them to use the keyboard to actually set the time. And there's tons of videos out there about that. I haven't made one yet for me, but maybe I will. Okay, lots of little examples. This is where I bought my two LCD boards, again on Amazon. There are a couple of ways to install the libraries, which were done in a previous video. I'm just going to skip that part here. Oh, I should mention this. I haven't mentioned it in a while. If you can't read even garbage on the screen very easily, there's a little set screw back here that you might want to adjust very, very gently until you can actually discern the letters on the screen. This just basically just talked about the pins that we're using. Yeah, A4 and A5 for the SDA and SCL. If you have a teensy 3-point something, you can actually use pins 17 and 16 to set up two I2C devices if you wanted to, and I discussed that in another video. I highly recommend that my students do not do that. That they just use the main the original bus and just use the little breakout board. This little guy here makes that just makes it so much easier than worry about the software. Okay. Again, in a previous video, I pointed out that these two screens have the same address. Okay, but I took this one and I put a little plug of solder on the A2 jumper here, and so this one has a different address. We should probably stop right there and let me show you what those addresses are. So if we run scanner, again, previous video showed you how to do that. All of these videos are linked below, and you'll see links to this to my playlist after the video is over. So we upload scanner, we run the serial monitor, and now we can see for mine we have four addresses. There are 4 devices at 4 different addresses. This EEPROM is really just a piece of the chip that is inside the, something's going on inside the teensy, and so that is what that address is. This address here, this OX68, this is the DS3231. This is the address for the real-time clock. Okay. This one here, the OX27, that is this little guy here, and that's the original, the small LCD screen. And then finally, the OX23 is the big screen. And again, I'm going to close this now, and we can get back to our main code here. There's the little table here that shows what the jumpers are for the LCD screens. Okay, so this is the OX27 when they're all open, and the OX23 when you jump the A2 pin, and so on. All right, so you can get 8 different addresses. You can have 8 different LCDs all connected together. All right, so let's get a little bit to the code. So my students, that this is a bit of a review. You can see that basically we're setting up the real-time clock here. Okay. And we have to create an object. This is the TM object, the time object, if you will. You can name this anything you want. TM is pretty common for time. And then we have this TM elements underscore T, and that's important. That's something you just have to do to create the time object. These little character buffers, these are buffer arrays, character arrays. This is 25 characters long, 15 and 15. I set this up. Most people don't use snprintf to print anything to the screen, but it's really useful to use this kind of function that is a little bit older, but it's really, really handy. Okay, so just know that we're going to be able to store characters into that, and then we're going to be able to print those to the LCD screen really easily. It's not necessary, but it sure does make life easy. All right, then we get to the LCD stuff. This is again covered in previous videos. We include the library, and again, you have to install the library. That was mentioned in previous videos, but also up in the header here if you just want to kind of take a look at how to install the libraries there. So I have one LCD screen, which I call LCD, and this is my OX27. This is going to be my little LCD screen. It's 16 columns and 2 rows, and then I set up another device, and I call that LCD2. You can call it whatever you want, and that address, right, we saw it on the scanner, is OX23, and then that has 20 columns and 4 rows. Okay, I really don't want you to use this, or my students shouldn't be using this. My students should not be using this. Not everybody has a Teensy 3.5, but still, I think it's not the best way to go. All right, so I set up the RTC, and so students, this might be something new to you. I kind of made it into a function. So when you scroll down here to the very bottom, this is the code, right, that you would see normally up in the loop. I just made it into a little function that sets up the RTC. All right, and let's just call this magic. All right, so this is what it's done. It's basically error trapping. If you're not able to sync with the RTC, it will let you know, or it will tell you that it has set the time. Okay, so we come back up to here, and then we say we're going to initialize the LCD and print some messages. And so this is our LCD initialization, and this is for LCD number 1, the small one. And we print hello LCD1 and start me up. Again, column and row. We're limited. We only have 2 rows here, and we only have 16 columns rather, on the first LCD. We have a little bit more space here for the second one, and so we're going to call it number 2. But still, I'm just putting it in exactly the same spots. All right, I am going to upload this code right now, and then you should be able to see these guys come to life. So let's see. So sorry that it's washed out, but here we go. And so you should see, yep, hello 1 and hello 2. All right, so the messages are printing, and now you can see that it's also printing time, LCD1 and LCD2. So let's take a look at how that code was generated. This is a little bit trickier, right? So far it's pretty standard. We set up the RTC, that's by itself, and then we print whatever messages we want during the setup, which only runs one time. I have a little delay of 3,000 milliseconds, so there's a little bit of a gap there. Okay, so now we have, anytime you have the real-time clock, right, what I would recommend is putting the code that you want to run inside this if statement. All right, so basically this is going to read the real-time clock, and it's going to grab the time, it's going to read the time, and if the time is readable, then it's going to run all this code, which I'll come back to in a second. If it does not, if the time is not read, it jumps down to here, and then there's some issue with the RTC, and we say drat. So again, students, I've kind of moved this into another little standalone function. It's just going to print the error message, and that's down here, and the error message is this if statement. Okay, so If the chip is present, then we say, hey, there's something wrong. The real-time clock has stopped. If the chip is not present, then there's some read error, and that's probably due to the fact that you've unplugged something accidentally. All right, so back up to the loop function, and we're inside the if statement here. So make sure all your code is inside the if RTC read. If you don't know what this is, I recommend you buy my textbook. It's in the first volume of my textbook. There we go, a shameless plug. And we're going to collect, in this case, into the time date buffer 25 characters worth, and that was set up, back up in the header. And we're going to collect 3 discrete data points here, and then 3 more discrete data points. And the first 3 is the month, the day, and the calendar year. And then the next 3 are hours, minutes, and seconds. This O2 says let's print it to 2 digits. So if it is the first month, it will print 0, 1, and not just 1. All right, and then we have the little slashes in here just for display. So this time date buffer is large, and then I do the same thing for just the time buffer. Here I'm just grabbing the hour, the minute, and the second, and that saves this time buffer. And I'm also printing things to the serial monitor, which is super handy. And then I'll do the same thing for the date buffer. Okay, and the reason for that is going to be pretty obvious down here with the LCD number 1. Okay, we can clear the screen, set the cursor to the top left-hand corner. 0, 0 is the top left corner, and then let's print the date. Okay, and then let's move it to the left, but down 1 row. So it's going to be the far left, but 1 row under. We're going to print the time buffer, and then we'll print LCD 1 over in the bottom right-hand corner. We have to break it up like this because the small LCD screen's too small to hold the time and the date on one line. That's not the case for LCD number 2. Notice we're going to use all 4 rows, row 0, row 1, row 2, and row 3. A little message here, just kind of showing off, and then that we can do it. And then we can print on the second row the entire time and date. And we're going to delay every second, and then that's it. So again, upload code. So we should get the hello, hello, and hello, number 1 and number 2. And then all of a sudden, boom, now we can read the time and the date. This one is ubiquitous. It's everywhere. This one's a little bit bigger. You can put more data. Students, y'all should be thinking about, how can we display all of our data on our environmental sensing station? It seems like that would be, this might be the way to go. Because you can just store so much stuff to show us. All right, there are more things you can do with all of these devices, but I think that's outside the scope of this tutorial, and I think that's everything. I'm sure I will think about something that I did not cover. Let me know in the comments if you would like to see something else, and I'm happy to get to that. Anyway, thanks for listening, and until next time, y'all take care.